In the previous session, we have discussed up to the matrix operations. Under that, we have discussed the addition of matrices as well as the subtraction of matrices. As we starting for this session, I will start this by discussing on the multiplication of matrices by scalar. First, if you pay our attention on what is the difference between scalar, what is meant by scalar. Actually, we can consider simply scalar is called as an integer. Therefore, we can say multiplication of a matrices by an integer. Since scalar is another term that we can simply use instead of integer. And if you are supposed to multiply a matrix by a given scalar, what you have to do is you have to multiply each and every element of the given matrices by the given scalar. And there is another concept called matrix multiplication. Please do not, these are two different concepts. Now consider about if A and B are two matrices, then if you multiply this A with B, then this is called as what we are saying as the matrix multiplication. Matrix multiplication. And now suppose that if you are having an integer called as 5 times A, then this type of multiplications are called as the scalar multiplications. Therefore, what we can do is there is a method for this calculation multiplication of two matrices. There is a way, but if you are multiplying a matrix by a given scalar, what you have to do is you have to multiply each and every term of this given matrix by the given scalar. Therefore, if you suppose that A is equals to 1, 5, 3, 8, 1, and 0. This is the matrix given for us. The dimensions of this matrix is given as 2 by 3, 2 rows with 3 columns. Now it is asked us to find the value of 5 times A. If you ask to calculate this quantity, then what you have to do is first we need to write down the integer or the scalar along with the elements of this given matrix, which is 1, 5, 3, 8, 1, and 0. Then we can multiply each and every term of this matrix by the given scalar. It is now 5, 25, 15, 40, 5, and 0. This is a 2 by 3 matrix. Therefore, we can see that each and every element of this matrix is multiplied by the given scalar. If I discuss another example on this matter, multiplication of a matrix by a scalar, suppose that matrix P is given as this way. If it is 2, 5, 0, minus 1, 3, 1, 3, minus 2, and another 0, another 3 by 3 matrix. And if you suppose to calculate the value of minus 2p, what you have to do is you have to multiply each and every term of this matrix by this integer minus 2. It is now 2, 5, 0, minus 1, 3, and 1, 3, minus 2, and 0. And if you perform this calculation, what you can identify is you can just have multiply each and every term of this matrix by minus 2. Then this will be ends up as minus 4, minus 10, 0. It is because you are multiplying each and every term or each and every element of this matrix by the given scalar. Then minus 2 into 2 gives us the value as minus 4. In this using the same procedure, if you continue the calculation, then we will get here. It will be minus 2 into minus 1 plus 2. Then minus 2 into 3, it is again minus 6. Then in this place, you will get as minus 2. Then for the third row, it will again minus 6 plus 4 and 0. Therefore, this is what we are getting as the value for minus 2 times p. This is some examples exercise given in this note. Therefore, we can try for this after This is the things what we have discussed so far in the previous session and in this session. Here in the first one, it is asking us to find out the order. If you we can try for this at the another time. Therefore, I will skip this part for now, and from another session, I will discuss each and every example given in this video as well. Then in the as the next session for this session, as the next part for this session, I will discuss about the transpose of a matrix. If we are going to discuss about the transpose of a matrix, suppose that we are having a m by n matrix, which is named as A. A is supposed to be a matrix which is having the dimensions m by n. It means that number of rows equals m, number of rows equals m, and number of columns equal n. Now, if you are having m number of rows with n number of columns having a matrix in this form, now we are going to identify the transpose of such a matrix. Generally, we are denoting the transpose of a matrix by AT. This is said to be this is a notation, not writing it as the tth power of A. It is not the way. This is just a notation only. And this sounds as transpose of matrix A. If I simply explain about the process of the transpose of a matrix is, it means that you are interchanging the columns as rows or vice versa, or it means or rows as columns. Therefore, if you consider the dimensions of this transpose matrix, now the dimension has to be also changed. It is because you are converting rows as columns or columns as rows. It means that now number of rows will become number of columns become number of rows, and number of rows become number of columns. Therefore, if you are having a matrix having the dimensions as m by n, then the dimension of the transpose of this matrix would be n by m matrix. It means that now you can see that number of rows is equal to n and number of columns equal to m. Therefore, this is how we are defining the transpose of this. This is how we are identifying or constructing the number of rows and number of columns in the matrix and the transpose of that matrix. And now we will see how we can obtain this transpose of a matrix. If I take this example, if A is supposed to be a 2 by 2 matrix, I will take this as 2 by 2 matrix. Here I will take the elements as 1, 2, 3, and 4. This is a 2 by 2 matrix. And if I suppose to obtain the transpose of this matrix, what I have to do is I have to change the, or I have to convert the columns into rows or rows into columns. In simply, I will convert the rows of this matrix into columns. Then it will give us the transpose of the matrix. If I obtain this simply, what I can do is here I am having 1 and 2 in the first row. Then it will become the first column of this matrix. The first row becomes the first column. Likewise, second row becomes the second column. Then this will become 3 and 4. Then you can see that since we are having equal number of rows and columns, we are having the same dimension for the transpose of this matrix as well. And if I discuss another example for this, if you suppose that A is given as 2 by 3 matrix, here it is 1, 2, minus 1, 5, 7, and 8. Suppose that this is the matrix given for us. It is a 2 by 3 matrix. Now, if you ask to obtain the transpose of this matrix, what you can do is you can have to convert the rows as columns. Therefore, if you select the first row, then it will become the first column of this matrix. Then it will become 1, 2, and minus 1. Then second row becomes the second column of this matrix. Then it will become 5, 7, and 8. Likewise, we can identify the transpose of this matrix. Since we have interchanged the rows with columns, then the dimension of this matrix will be equal to 3 by 2. And if you consider about the transpose of a row matrix, now think that if X is given as a row matrix, suppose it is given as -1, 0, and 1. This is a 1 by 3 matrix. If you consider the transpose of the row matrix, then it will become a column matrix. Therefore, it means that the first row will become the first column of this matrix. Since we are having only one row, our matrix will only have one column. That is why we are getting this as a 3 by 1 column matrix. Therefore, if you are take the transpose of a row matrix, then it will become a column matrix. And we will consider another example for transpose of a column matrix. If you consider the transpose of a column matrix, suppose that y is given as -2, 5 and 3. This is a column matrix given for us, and if you are asked to obtain the transpose of this matrix, then you can get this as -2, 5 and 3, which is supposed to be a row matrix, since we are having only one row in this matrix. That is how we are obtaining the transpose of a matrix once the matrix is given for us. Based on this concept of the transpose of a matrix, and we are going to combine this concept along with the equal matrices. Suppose that if the matrix and transpose of that matrix are equal matrices, then it is supposed to be, we are saying A is a symmetric matrix. A is a symmetric matrix. Therefore, to identify the symmetricity of a matrix, we can use the concept of transpose of matrix along with the equality of two matrices. Therefore, if a matrix and its transpose matrix are said to be equal matrices, then we can say that the given matrix is a symmetric matrix. If you discuss or if you consider this example, if A is supposed to be a matrix given as 2, 3, 3, 1. This is a 2 by 2 matrix, and if you consider the transpose of this matrix, then what will we get is first row will becomes the first column. First row becomes the first column. Now it will be 2 and 3. Then second row becomes the second column. Then it will be 3 and 1. Now, if you consider these two matrices, now check about number of rows are equal, number of columns are equal. And if you pay the attention on the corresponding elements, you can see first row, first elements are equal. Second row, second element, we are having 3 in the both places. Then it is first row, second column, then second row, first column, second row, second column. We can see that each and every corresponding elements are equal. Therefore, we can say that A and A transpose are, or the transpose of A are equal matrices. Therefore, we can say that matrix A is a symmetric matrix. This is how we can define the symmetricity of matrix. And if I consider another example for the symmetricity of these matrices, here I will take this as 1, 3 and 7, 3, 5 and 2, 7, 2 and 0. This is a 3 by 3 matrix, and if I consider about the transpose of this matrix, then what we will get is first row becomes the first column. Then it will become first column as 1, 3 and 7. It is because in the first row, we are having 3 elements as 1, 3 and 7. Then second row becomes the second column of this matrix. Then this will becomes 3, 5 and 2, since it is the second column. Then using the same concept, we will write down the third row as the third column. Then it will become 7, 2 and 0. Then this will become again a 3 by 3 matrix. And now if you consider about the matrix A and the transpose of this matrix, first you can see that equal number of rows are there, equal number of columns are there. Now if you check for the corresponding elements, you can see that all the 9 elements are equal, or the corresponding elements with these two matrices are equal. Therefore, we can simply say that A and transpose of this matrix are equal matrices. Since this equality satisfies, then we can say that A is a symmetric matrix. Using this concept, we can now identify the symmetricity of matrix. And we can define the symmetricity of a matrix, or we can identify the symmetric matrices only for the square matrices. If we are identifying any symmetric matrix, that should be a square matrix, not for the rectangle array of matrices or rectangle array of numbers. We are not be able to identify the concept symmetricity. And if you see about if you are taking this matrix, since we know that this is a symmetric matrix. Now, if you are folding this matrix along with the main diagonal, now you can see that these two elements are coincide. Therefore, this is the property of a symmetric matrix. And if you do this, do it for this part as well, or the second example. Now, if you fold this matrix along with this main diagonal, then you can see that these points are coincides. Now you can see that 3 and 3 are coinciding, 7 and 7 are coinciding, 2 and 2 are coinciding. Therefore, this is the property of a symmetric matrix. It means that if you are folding the matrix along with the main diagonal, we can see that the elements above the main diagonal are coincides with the elements below the main diagonal. It is a special property of a the symmetric matrix. And the next thing is, each and every symmetric matrix is a, we can say that every symmetric matrix is a square matrix. And now we will move for the next part. It is the matrix multiplication. And this is the last topic that I am going to discuss for this session. And now if we are discussing about the matrix multiplication, when you are discussing with the matrix operations such as matrix addition and matrix subtraction, first we have identified whether the matrices are confirmable for matrix addition or matrix subtraction. In that situation, what we have, or in that case, what we have checked was the number of rows should be equal, number of columns should be equal. It is the condition which is need to be satisfied if you need to perform the matrix addition or matrix subtraction. Now we will discuss, when we are going to discuss about the matrix multiplication, there is also a condition which should be satisfied to obtain the matrix product. We'll consider, let A and B be two matrices. Suppose that A and B are two matrices. And if you are supposed to obtain the matrix product AB, suppose that this is the product that you need to obtain, matrix product AB. If you are supposed to obtain the matrix product AB, then there is a condition that should be satisfied. It means that if you are considering A as the first matrix, number of columns in first matrix, number of columns in matrix A should be equal to number of rows in matrix B. It means that simply, if you are considering the product, if you consider the order of this product, it is matrix A is multiplied with matrix B. Therefore, first matrix is A, second matrix is B. Therefore, number of columns in first matrix should be equal to number of rows in second matrix. If this condition is satisfying, then we are saying that matrix A and B matrices are confirmable for the matrix product AB. And suppose that if you are having the order or the dimension of the matrices, suppose that A is having a matrix having the dimension, the order as m by n. A is a n by n matrix and B is supposed to be a n by P matrix. Now, if we need to identify this matrix product AB, what we need to do, check first, what we need to check initially is whether the number of columns in first matrix is equal to number of rows in second matrix. According to this example, our first matrix is supposed to be A and second matrix is supposed to be B. Then we can see that number of columns in first matrix is equal to number of rows in second matrix, then we can say that matrices A and B are confirmable for the matrix addition. Then we can obtain this matrix product as matrix AB, and then we can, if we identify the dimension of this matrix, then we will get this as this is matrix AB having the dimensions M by P. It is because M comes from the first matrix. Since in this order, your first matrix is A, M comes from the first matrix and P comes from the second matrix. Therefore, this is the concept or this is the condition that we need to check for the confirmable for matrix multiplication. And if you are considering about this way, now suppose that A is a matrix given as M by N and B is a matrix given as N by P. And suppose you are obtaining this matrix BA. Now your first matrix is matrix B, it is N by P matrix. Second matrix is now matrix A, it is M by N matrix. Now if you are trying to obtain the matrix product BA, then if you check for these two values, now you can see that these are not two equal values. Therefore, the condition is not satisfying. Therefore, A and B are, we can say that A and B are not confirmable for matrix product BA. Then you can say that A and B are not confirmable for matrix product BA. This is how we are identifying whether the matrices are confirmable for product. Therefore, in generally, we are saying that matrix product AB is not equals to BA. This is the general condition of multiplication of matrices. And in the next session, I will discuss about using an example, the way of obtaining the multiplication of two matrices. And this is all what I need to discuss for this session. And thank you all for participating in this session.